Hello, good afternoon everyone, and welcome to this Chillventa special roundtable with Karel. First of all, let us apologize again. Unfortunately, there was a small blip in the system, so the link published by the platform, the Chillventa platform, was not the correct one, but the previous one. So we hope that all the other attendees, and we've seen a lot of interest for this roundtable, could join in a few minutes, but in the meantime, we have to start with our session and with the people joining. So if you can spread the news, if you have colleagues who are planning to attend, please share with them the correct link that you obviously found as you are here with us. Welcome and good afternoon again. It is strange to meet at Chillventa like that. Normally we were at this stage in the afternoon, we were thinking of a possible beer and a bratwurst together in the evening in Nuremberg. But now we know that the world is finding some new normal and still things are continuously changing. The topic of today is somehow related, and we are going to talk about high efficiency technologies for HVAC in process cooling. Every time we are discussing about this topic 1 year ago, the common feedback from many operators in this sector was process cooling is mission critical. It's paramount reliability. The unit doesn't have to stop. I need to provide cooling continuity to get process continuity. That's the main driver. I really don't care about energy consumption. But as any crisis in the world, like the one we are living with, the pandemic, we know that many phenomena are simply becoming quicker with this one. So despite the global economy downturn, we expect that some processes might be accelerated by this crisis. And one of them, possibly related with founds and so on, in the process cooling, might really bring again the spotlight over energy efficiency. Who knows, maybe some founds can be given only if a certain efficiency can be matched, even with the process cooling technologies. As a matter of fact, then we will have two presentations today joined together by a common topic, which is finding a way to save energy and at the same time guaranteeing business continuity in all processes and all the process cooling. We will have the two gentlemen speaking. Let me introduce Marco Piovan. Marco Piovan is
hello everyone.
Application
hi
Enrico. Hi there.
Yeah,
we are still allowed to do that till rules are not changing. We are still respecting the distances here. And Matteo Venturi, who's a product specialist instead. Again, for process cooling. Welcome, welcome, and thanks to everyone attending. Now we reached almost 50 people. Let's go on, keep sharing. We are here for you. So, have a seat.
Let's make ourselves comfortable.
Yes,
we are sitting at the round table today.
We are just imagining, and we really thought that was the correct format, because it's more or less like being at the show. So, beer is not here. We don't have the products. A couple of them on the table. It's not easy for you to touch them, but this is the idea. Having a little bit more than a simple presentation on the round table. So, few basic rules. We want to make this as interactive as possible, as if we were at a crowded booth at the show. And so, we will use a couple of polls probably. We will definitely have some presentations. You cannot help having some slides here. And in the end, we would like you to be interactive, posting all of your questions. I don't know if everyone is familiar with the Zoom platform. In the meantime, we reached 53, 54 attendees and growing and counting. Please go on. We have room up to 100 people, but we had many, many more. Unfortunately, I do apologize again for the people just joining in. There was a small blip in the system, so the link in the eChillventa platform was not correct for our Zoom platform. Hopefully, they will send a message soon. So today we are going to speak about that, but if you have questions, maybe you're not familiar with the Zoom platform, I was saying there are two buttons you find at the bottom of your screen. One is chat. Please use the chat for service messages as we used, so questions that you might address to us for having an explanation more on the platform, how it works, can I talk, how can I do that? Whereas we would like to keep the question and answers button. It's a specific session for questions on the matter that we are today presenting. Having said that, I think I will pass the torch to Marco Piovan for the first presentation and the first session regarding process cooling.
But we will make it an interactive one. So, of course,
Matteo will join. Of course, you are very welcome to intervene and make a lot of questions. This, we are sure, will help clarify this matter, and it will be just the beginning of that, hopefully in the near future, and then for the entire eChillventa show, we will be available to answer your questions and our colleagues to get into contact with you. This is what shows are supposed to be made for, and this is what we want to achieve.
That's right. So I think, Enrico, a very good introduction to this session, and thanks a lot for what you just said. I think that efficiency will have a lot to do in common between my presentation and Matteo's. So I will focus a bit more on the chiller management. So I'm talking about a new controller that we just launched to the market, specifically made for process chillers in production lines. Whereas maybe Matteo, just a few words about the thing you will focus on.
I'll be dealing with the use of the humidification to raise the efficiency of maybe old dry coolers. So I'm sure you'll be
even in a retrofit perspective.
Yes, of course, for new and for old installations. So
yeah, that's a very good
common effort to reach the energy efficiency. We need to consider both the new installations and retrofits. Yeah, so one more focused on the chillers, on the cooling machines, and the other one, other processes, higher temperatures. We will see a little bit of that and how they might interact.
Yeah, that's right.
Let me say this, talking about a new product sounds strange in this very moment, but probably some of the things we will see are right in this very moment becoming very important. So we will see a little bit of that.
And that's for sure, it has to do with eco design and the F-gas regulation that affects process chillers a lot. Both of them are trying to reach carbon neutrality in the long term. You know, the European Union has a very ambitious goal to have a net increase of CO2 emissions equal to 0 by 2050. So there's a number of measures that the EU, I'm talking about the EU specifically because this is a European, based event. We might have also people from the US
joining from other countries, overseas. Welcome to all of you.
Yes.
And once again, we do apologize.
But coming back to these two things, the eco design and the F-gas regulation, they affect process chillers a lot. So there's a specific efficiency that is now that chiller manufacturers have to calculate, and it has to do with the seasonal efficiency. So it's a bit complicated also, measurement that takes into account the different temperatures over the year. And the efficiency required by such norm is becoming more stringent over the years. When I think of process chillers, the NLO 21 is calling for an improvement in the efficiency in the next couple of years, and there might be also a revision next year coming that will further, strengthen the efficiency requirements. So everyone probably in the process chillers, process cooling world, is looking around, is very aware, and must be also careful about what's going on.
Both minimum efficiency as it is now, the energy lots and so on, but who knows, maybe even everyone these days is talking about the recovery funds. Maybe this can be linked to, as it is, for example, now for the comfort cooling, it might be linked to a certain level of efficiency.
So, by the way, I don't want to have too much of small talks. I'll challenge you first of all with one thing, differently from what Enrico said. I would like you to type in the chat that is available on Zoom, so everyone can see what you write down. What's the most important feature today in the chiller you manufacture, or let's say if you're not a manufacturer, that you think is the most important feature today? Don't think too much of the regulation, not your desire, but today what you think is the most important feature. Let's see what it comes up, because I think it's a very...
This rolling till...
let's see, like don't be shy, please, don't be shy, and type down something. So while you type down something, I'll maybe start off with the PowerPoint presentation. So I prepared some slides in order to give you some guidance. So it's easier for everyone also to focus on the concepts we are trying to deliver today. And the presentation is about a new product, as I anticipated before, that is trying to respond to all the needs that we have been talking about so far. So it's a product which name is a micro chiller process. Micro because, as the word says itself, is compact. You have a couple of pieces here. You see my hand. Oh, well, it looks like this is a panel version.
You have big hands, but it's not that big.
My hands are small, so also the product is
4D modules.
4D modules. Okay. So it's a compact product, which aim is to provide you with the management of all the common features that are required in process chillers, but also it gives you the possibility to somehow comply with the new regulations that are coming on. I'll use this controller to start off with a presentation. So trying to advance to the next slide, it doesn't work. So Enrico, maybe you can help me out.
No?
Try.
Okay.
Okay, it's coming, perfect. So which are the pillars of this product that we have just released to the market? First of all, the usability. As I said, we understand the process chillers have been made for many years in a certain way, so we are giving you the possibility to manage the old design that you've been delivered so far. So things like the hot gas bypass management, rather than two pumps, one the main pump and the backup pump. We understand it's a process. You don't want to add any disruption in your...
If it works, don't change it. Many people are still
so you still have the chance, as Enrico just said, to have the complete management of the business as usual chillers. Nevertheless, there are some very important things today, like connectivity. Everyone is calling for connectivity, but sometimes in a production line, connectivity could be also meant as accessibility to the unit.
Oh, wow.
Well, for example, I mean, Enrico, you know better than I, where could it be installed, a process chiller? In a very handy place, or maybe on top of the ceiling?
Yeah, depending on the equipment that it is cooling. On top of that, you mentioned connectivity and accessibility. I would say it's also more and more remote connectivity, or the possibility to use tools to do remote maintenance. That was important.
Correct.
When we were talking about usability, probably now the technicians during this lockdown, they couldn't go in the installation, so they had to do some remote troubleshooting.
Yeah, what about, you have a chiller being installed by the end user somewhere, I don't know, on the other side of the world, and the fault happens. Now you don't have any visibility of what's going on in a business as usual scenario, but what about if the maintenance guy there in the production floor can download the data and share it with you when it comes to a fault, so you can have an overview of what was happening right before the fault. You might already give, you know, some directions to whoever is running the machine to have a first intervention on the maintenance, and you may also save the money of sending some guys out in the field. By the way, have we received some feedbacks from the chat? Everyone is very shy.
Yes, they're very shy. I'm pushing that.
Okay.
Use the chat. Maybe they don't know how to use that, but still, while we are doing the presentation,
yeah, sure,
keep using that to post your comment on what is the most important feature of your chiller, if you are a chiller manufacturer or if you are a chiller user.
We would really like to comment on that later. Coming back to the product, as I said, it's very important to have the accessibility to the machinery when it comes to, for example, a fault. Now, microchiller process is not a solution probably for every chiller, and the slide that you can see now gives you an idea what's the focus that we have decided to give to this development.
For this particular product.
This particular product. Karel does have other solutions, of course, that are even more versatile and can even manage big chillers of 1 megawatts and above. But our expectation, at least for this product, is that the vast majority of process chillers as auxiliary to production lines will be in the range of 10 to 30 kilowatts probably in power. Nevertheless, microchiller process can manage a much bigger chiller as long as you have one circuit and two compressors. That's a very important thing to keep in mind, and you can see also on the slide that has been just shared. Now then, there's a number of other things that come together with microchiller process. For sure, the management of an electronic expansion valve, that is a very important component in order to meet higher efficiency standards, and so also variable speed compressors. So I assure you guys that you can benefit of all the work being done by Karel with the BLDC compressor so far, and all the libraries and all the data of all the qualified compressors are being made available for the solution. How sounds, Enrico?
Sounds good.
Great.
I mean,
and to you,
Matteo. Yeah, sounds great.
Yeah, sounds good. You would buy it, right?
Ah, definitely.
No, I mean, this is right on time, because someone is starting to post their comments, and they're saying, yes, high efficiency, for what we said before, is becoming paramount, but still they need to have something that is really reliable. So someone was posting reliability as the most important characteristics. I have to say that this technology now is very much reliable. Yeah,
absolutely. I mean, the platform, talking about the controller itself, it's definitely a reliable controller that has been already delivered for a number of applications, and the algorithms that we have embedded have been already proven in a number of applications during 30 plus years of experience. So the heritage for sure has been part of the development. And coming to another aspect of reliability, if I may say, we understand that reliability to the end user is having the process operating fine all the time. So that means probably in a process application, you really don't want to turn off your chiller unit anytime unless really safety is put at stake. So it's your choice. We give you the handles for this to decide if there's a process priority in the management of your chiller rather than a number of other, for example, threshold for waiting time on the restart or compressor and so on, that usually in comfort application tend to preserve the unit.
Save the compressor.
Save the compressor. You want to save the process.
All right.
Okay? So you can select that. It's up to you.
It's important. You can pick. Oh, this is a very good point. Anyway, the variable speed compressor was always seen like an energy-saving technology, or for process chillers as a possibility to control the supply temperature.
Correct.
But we never thought that Actually, this is increasing reliability because with the envelope control, you are limiting, for example, the speed of the compressor depending on the conditions. So if your condenser is dirty, maybe instead of tripping a high pressure alarm, you're just limiting the speed of the compressor and trying to provide some business continuity.
Okay. Yeah. Maybe let's keep going with the presentation. This tool is not working. So
perfect.
Maybe can you help me, Enrico? Sorry with that.
We are here to face all possible inconvenience. All right.
Okay.
Try again.
So, as Enrico said,
there you go.
Okay. High efficiency in one thing. Of course, connectivity is another big thing. So, Matteo, you're younger than I. What do you expect from connectivity on a today device?
Well, I expect, of course, that from my smartphone I can connect to everything, because otherwise I won't buy it.
You're out of the game, right?
Yeah.
And so we are definitely giving you the chance to use your mobile phone. So you see this one for doing a lot of things. On the slide, we summarized pretty much what you can do with the log data. Yeah. So there's also a snapshot of the interface of our app that you can use. You can download anytime. It's free and downloadable both on the Apple Store and the Android Store, the Play Store. So I think I would like to show you a little bit. Maybe we can have
a demo?
Yeah, like a demo.
Right.
So there are two ways to interact with the device with an app. One way is live with a Bluetooth connectivity. Yes, Bluetooth connectivity, and that permits you to interact live with the controller. Today, even if it looks like not the most sophisticated and upgraded, I would like to show you the basic one that is on every controller, that is via the NFC. And there's a reason why I would like to share that, because NFC works even when the controller is off. So that means if you want to check the parameters on your controller prior delivering the chiller unit, or you just want to do a check prior dispatch, for example, in the warehouse, you can just tap on the unit and you can see what is in there. And
without powering the unit?
No power.
Okay.
So it's the same technology when you pay with your credit card.
So typically you manufacture the units, you put them in the warehouse.
Correct.
Special setting for that job, you can download.
So let's see if technology helps us this time and it doesn't crash.
Let's try. Technology was letting us down.
Okay, so I'll start off with opening, let me do it again, sorry.
Of course.
Opening the app of Carel, that is, which name is Applica, is common to all the Carel devices. So now Applica should be launching. You see, I'll get closer to you, maybe you can see. So now it's uploading and the controller is off. You see, there's no power. So let's see what
you make it look like a magic trick.
No, there's no magic trick behind. So now I will go for NFC connectivity. All I have to do is to tap it on the controller. Now you can see that the app...
So this is going on the cloud.
Correct. So the app is recognizing which kind of device it is connected to. So it understands it's a micro chiller process. All right. So now the app is downloading some data from the cloud. It understands what is the device, because then all the parameters all of a sudden will pop up on the app, right, as for the configuration. Now, just a little bit of time.
It's the first time on our connectivity. So on the phone connectivity.
And also how often used, because this is the first time I do it with NFC, so it takes a bit more to download the whole interface.
So, basically, it's finding an identifier.
Correct.
Okay, so you can understand which type of unit.
There you are.
The app is the same.
Okay. Yes.
Okay. Now, now we have
select
all the parameters.
The profile. You can set up a password, so it will be very simple: 1, 2, 3, 4. But just, you know, and start off for the manufacturer.
It's not hacker-proof.
Correct. So now you're in. You see that there's a number
of menus.
The unit
is still off.
Yeah.
The unit is still off.
The unit is still off, you see. Now, it's in Italian, but don't worry. Wir sprechen Deutsch, hablamos Español. We speak all the languages.
Right,
so my phone is, or not an iPhone, it's a Huawei phone. So it's in Italian, so you see Italian, but then you can set up your language.
So as it comes to Italian, this is showing that we read the NFC memory
Correct.
Today at 70 minutes past
That's
4.
right. So now set up
So this is the
for
code.
any language. For example, I'll show you how it comes that we can also change parameters if we detect something is not okay. So configuration of the unit, you will see all of a sudden that a number of parameters, that's a guidance for you to set up the unit configuration will appear. So let's say I detect that there's not one user pump, but rather I would like to have 2. So what I can do is to change this parameter.
So a twin set of pumps for
Correct.
redundancy.
You see, it's not 1. I'm going to override this and say 2. And all I need to do down is click on the top icon and say, okay, I want to apply this thing. All I have to do, tap it again, and now I've written the configuration. Now the unit understands that it's 2 user pumps, and it's done. You don't need power.
In the meantime, the unit was never
correct.
powered,
You see,
so
you can see now it confirms it's 2 pumps, 2 user pumps now being set up. And I think that's all for Applica. Maybe we can follow with the presentation.
Yes, of course. The good thing is that we are used to have a small device like that with a small display. The first thing that Matteo mentioned was I would like to connect that with my smartphone, because as a matter of fact, the smartphone is becoming an extension of our hand, and we don't want to go there and input parameters one by one with an alphanumeric name. You would like to have an extensive, extended description and so on. And this, as a matter of fact, is becoming normal. And so, yeah, usability, especially in certain contexts.
I'm not sure if I satisfy the expectations from Matteo. Does it look...
well, it looks like a magic trick for real. Yeah,
that's good. Okay,
yeah, nice. you should share that directly on Instagram.
Yes,
anyway,
you should.
Okay.
Shall we go back?
Yeah, I think have we received more things about today in the chat? Let's see if we got more.
We do have
reliability.
There is a question here. Interesting. And yes.
Is it that interesting that we want to respond now, or we keep it for later?
we would like to collect all of them and then possibly answer in the end, or address directly the question to, if it's very specific, directly to the one who made the question.
That's okay. So then maybe I will tease you with another way around, because in the chat I asked you to express what the need, in your opinion, what's today present on your unit. But on the poll I prepared for you, so maybe Enrico, you can help me to launch the poll. It's about the desires that what would you desire later on in your process chiller. So with the help of the iPad, I will guide you.
So I'm launching the poll.
All about the process chillers, what you desire. It's another poll, sorry, it's the last one.
Oh, okay.
There you are. Perfect.
We start from poll number 3. This is interesting. Yeah. All right.
We keep it flexible, so we decided that it's the time for the poll number 3, at least in our list.
Okay.
So
let's launch the poll.
Let's launch the poll.
Please go on.
Just a sec. There you go. So what is the most important feature you would like to have in your chiller? So this is about your desire. Please select one of the followings: precision, versatility, high efficiency, or connectivity. You have to choose one. You don't have the option of choosing 2 or more. So you have to make your choice of what's the most desired for the future. So,
I mean, I already answered the question. For me, is of course connectivity. I think it's definitely.
Answers are coming. Please go on.
Please go on. So let's give a few more seconds.
Few more seconds. Yes.
So in your opinion, Matteo, connectivity is a very important.
I mean, of course, they are all very important characteristics that you cannot last, but I think connectivity is the one that is good for me. So. Okay,
that's great. So 5, 4, 3, 2, 1. Okay, let's see the results. High efficiency. by far, because it's 54%. So I mean, it's perceived as something probably that is missing today, you know, on-off machines most of the time.
I think many of them are going through possible redesign of their units. I know many manufacturers in Europe have to do that to cope with the requirements, especially for the single compressor chillers, to cope with the requirements of the eco design. So they are changing the fans, updating the heat exchangers and so on.
Yeah. So I think that then it's a good chance maybe to focus on high efficiency in the rest of the presentation. So if we can switch back to the PowerPoint, I think we should cover now the slide we prepared about the common features for all the models of microchiller process, because I think it's a valid support to reiterate and also explore a bit more about the functionalities. So the logs, as we said already, it's something that can give you the opportunity to understand what's going on.
Are we going to elaborate a little bit on that, just to close the connectivity topic?
We can do that, and then we switch to
as you wish. We can move
the
back
logs,
if you want.
let's do that first. So the logs is something that, as I said, gives you the chance to look at 20 variables record for 30 minutes prior a serious fault has happened. So the way it works is that the maintenance guy or whoever is present in the production line can access via Bluetooth connectivity and download
something
the logs.
that any maintenance people could do.
Anyone can do, even your mother or your grandma can do it. So they just need to connect to the unit. Maybe even
your grandma knows.
She's very evoluted.
Yeah, smart grandma.
High technology.
So you can download. This sounds like a black box behavior.
That's a very good comparison. Okay. So you know, and you don't have to pay insurance for that.
So you can download the log, and then the app is opening automatically the tools like sending via email, sharing as a file.
Description and alarm and an Excel format of with all
the last 30 minutes. So you can do a better troubleshooting even remotely. Because we know these units, I don't know, that could be another good poll for you or a comment in the chat. If those units are directly connected to any remote device, or if instead more often they are connected to the unit itself. So it's the main unit that is connected to the Industry 4.0 or whatever. All right. So we move on to the high efficiency.
And then I think we can leave space also to Matteo's presentation, which is even more important. Now, all the features that you will find in any model of microchiller process. Of course, there will be different models, some for just basic units that will be less expensive compared to units that also include high efficiency, so the variable speed compressor management. Nevertheless, let's focus on what's always in there. So, as we said before, it's a process machine. It never stops. It must ensure that your process is relentless. It's a cooling-only mode unit. We don't expect that on your process chiller you will need to have a heat pump mode. If you need it, we have a different version of a micro chiller that can do it. Is a reversible unit. But micro chiller process is just focused on cooling. The hot gas bypass management, it's very important. It's a dissipative mean, but it has proven to be really fast.
By far, traditionally, it's what everyone was using.
Okay. So even if it seems to be against the current trends, we've made it really versatile. So you can set it up with an SSR relay. By the way, it's embedded, so you don't need to add an extra module. We give you the SSR directly in this controller, all right? Okay. And we expect that it will be able to drive most of the valves that are being used for hot gas bypass management. It can be done also with the current XV, and we believe that's the most precise way to manage the hot gas bypass.
And probably also more stable for the condensing pressure and so on, being able to modulate the opening of the valve.
But coming to high efficiency, that is, of course, very, very important. High efficiency is something that can be done via, in our opinion, a BLDC compressor, which is proven to be a very compact kind of a compressor compared to the power it can deliver. So we understand it's probably a small unit, there's not much space within the chiller, you also want to have something that is compact. So we're not only giving high efficiency, because BLDC technology is for sure one of the most efficient, but we also give you the chance of having a very compact compressor, considering the output that you can provide. Now, all the experience of Karel, the algorithms that we have been developing for the various applications where Karel has been providing products for have been included in the management. So all the tricks to keep keep your unit undergoing are there.
Yeah, it's inside the family of products.
It's inside the
so
family.
It's sharing the.
But there's one addition. There's one addition here. The BLDC compressor can work together with the hot gas bypass. It might look a strange thing, but it's the best way to have a very precise and efficient.
And any compressor has a minimum.
Of course, it has a minimum
speed.
That's right. But one thing is to modulate via compressor. Another thing via valve, which response is much faster. So if you need a very fast response and you want to keep
especially
the unit on,
when you're close to the minimum and you want to control very precisely in some medical applications and so on.
And you have the freedom to set up the parameters of the hot gas bypass intervention the way you like. So I think it's a very nice thing. Last thing, and then I will really give the floor to Matteo fully. It's about the independent auxiliary loop with auto-tuning. And that's a very interesting feature because it gives you the freedom to manage an independent regulation. So for example, your chiller is meant to be regulated the outlet or inlet water, right? Because chiller makes cold water.
Supply, return.
Correct. Okay. But then you might need a thermostat, you might need to regulate a modulating user pump. You might have a different need from time to time depending on the project. So we thought about why not giving out a regulation that is completely independent from the main one and which PID parameters can be set up independently with the addition of what? Of the auto-tuning, because sometimes you don't know the physical response of your system because every installation is different. We give you the possibility to find out the best PID parameters should you not know which are. So now, I mean, we have little time. It's not the right arena to dig more in the technical stuff, but our people.
It's. I think this is good because we just received an answer about flexibility and
that's a
this
example.
feature is making this product, which is a parametric one, kind of programmable because you can input any type of loop and an additional one. Yeah. So you keep the device simple in its main functioning, its main parameters, but then you can add something that you want and you can link it to the main behavior of the unit. All right.
I think it's fair enough.
Yes, we have a few questions. One is interesting. Maybe it's just for a debate. You mentioned, you kept mentioning the hot gas bypass. I don't know if this question is for you or for the entire audience. Is hot gas bypass still compatible with the eco-design regulation?
That's a very good
question. What do you think about that? What's your opinion?
I think you should wait till the end. So I keep you there. You have to wait for the answer because I have an idea.
You have an idea?
I have an idea, but I'll respond after Matteo's presentation if you don't mind.
Good. Okay. This is a very good teaser to keep you in the loop.
To some discussion and more questions maybe from the audience. I have an idea, but I don't pretend to say it's the response.
All right.
This is an incredible cliffhanger that's going to be thrilling for everyone that's listening.
You will know that in the next presentation, at the end of the presentation.
You won't sleep at night until you...
we are closing this, just leaving the slide with different models that you were mentioning.
Yeah,
so,
okay, just a few words. There's a basic, it must be a scalable solution. Not everyone is in need of a variable speed unit. So we understand if you don't want that, you probably expect to pay a little bit less. So there will be a basic version. Then if you think about the management of an expansion valve, electronic expansion valve, then you probably need for the enhanced model where the embedded driver provides you, with another feature within the same controller without an external module. And then the top version is coming with the management of variable speed compressors. I think that's
excellent.
All. Thanks, Enrico.
So thank you, Marco.
Thank you. Thanks to you all.
You're passing the torch to Matteo for his presentation. In the meantime, we stop sharing just for a second, just for the introduction, if you don't mind.
Yeah.
So very good. We've seen a few characteristics of this new product that could be an idea to develop high efficiency units, which might be a need, and also more usable units, easier to maintain and easier to be connected with a smartphone as the millennials. And it's not only the millennials, you mentioned grandma, but I think many of them are now expecting to get more information, and if they can get some information and dispatch them to the technicians, they can have immediate support in front of the unit, sharing like the logs that might help them do the correct troubleshooting, because they might not be able to reach the plant as it happened. So we hope this is going to be over, but nevertheless, everyone is putting that into account. So it's changing the way we are all living. Here, we were paying attention to distances and wearing face masks and so on. Very good. In the meantime, let me just welcome all the other ones who joined recently. We reached more or less 75 people at the moment, so very good. Again, we do apologize. I really hope we did not miss anyone. We started with a delay for a blip in the system, a glitch that was related to a wrong link in the platform. So this is the magic of copy and paste, probably. So there was the old link there. So in the beginning, it was not possible to connect to this webinar. Nevertheless, welcome. We do apologize again, but let's crack on with the second part of these high efficiency technologies for HVAC cooling. We've seen something for the small process chillers, small to medium. Some of them might be inside, close to, I don't know, injection molding machines.
I'm really curious to understand what's going to happen.
There are several
on the top of the
processes,
roof, right?
Yes.
Yeah,
we have other processes, and there are a lot of possibilities to save energy. And I'm really wondering whether there might be a connection between the two things. We were discussing about refrigerants, new refrigerants. I can envision this is going to be a very big debate with all of you guys, and any comment on that would be, or any feedback from you would be really, really appreciated. What would be the new refrigerant for the future? I don't see flammable A3 refrigerants going in a factory, especially to heat source. So maybe we will have more chillers outside, or maybe we will have chillers with a reduced refrigerant charge. So we would like to possibly boost the condensation. What will happen? This is definitely a link with this, the second part of our presentation with Matteo.
Yes, indeed. So thank you, Enrico, and it was a fantastic presentation from Marco. I hope I'll be as interesting as you were.
You will be for sure. Come on.
Thank you. And so, yeah, I'll be dealing with the increasing of the efficiency using evaporative cooling in dry cooling, in dry coolers, old dry coolers or new dry coolers. So my presentation will be a little more standard, but I hope it will be.
Well, for sure, we'll ask you questions if something
yeah.
pops
So
up
I hope
to our mind.
to get more and more questions, so it will be more interactive and we can have fun. Let's say.
Yeah.
So I think we can.
In the meantime, I'm trying to type and check the questions and in the chat. So very good. So
I
we can
think,
start sharing?
Yeah, definitely.
You ready?
I think you should.
Very good.
So yeah, I mean, we will start discussing about the needs of the industry. We have partially covered with your presentation, but I think it's going to be interesting to see another point of view. So I think
Definitely
that okay, it's not working here.
Yeah, we are fighting a little bit with the technology today. Okay, that's why everyone was pointing out that reliability is definitely the most important characteristic for that.
This thing is not reliable. Okay, so yeah, again, we start with an introduction. We'll see the needs of the industry and how we can solve those needs. Then we will present our system that is going to solve those needs. And later on, we can present some experimental data to see that the system is actually working.
What everyone
I hope it is going to be the most interesting part of the presentation.
Definitely.
And later on, the installation to see how our system can be applied to many different shapes of the dry cooler. Because of course, as you know, we got many geometries from vertical, V-shape, horizontal. So we'll see.
Main topic is.
So there's a solution for everyone.
Yeah, there's a solution for everyone.
That's good.
Okay, so we start with the needs. So it's work. Okay, I mean,
he fixed that.
So the needs. Again, I'll start with something I'm sure you already heard 100 times, and you'll hear in every presentation from now on saying that the world is changing. One of the biggest change apart from the pandemic is, of course, the climate change. And this is changing not only how nature behaves, so the average temperature is rising, and it's the fact that we actually feel year after year, but it's changing also how we turn to technology. Because again, from the poll you just presented, we saw that now high efficiency is crucial. So what happened? Every year after year, there's a growing awareness of this problem. So we turn to technology and say what we can do. We are part of the industry. What can we do to increase and try to solve this problem? That's why many of we start hearing about natural refrigerants, and that's why again a crucial part of the debate is about efficiency, energy saving. So again, we are part of the industry. What can we do? Is it not working? So
coming and going.
Yeah, coming and going.
Let's go for the next slide.
Yeah, okay. I think it's better.
Let's use the digital technology.
Okay, so yeah, I've divided. This is, of course, is a big division, but I've divided all the processes in three. Starting with the processes with high temperature water, let's say more than 50 degrees, and where you may just need an evaporative cooling tower, to cool the water that you're using for your process.
I'm quite sure that between the attendants, we've seen some of the producers, the manufacturers of this industry. So,
or you can have processes with low temperature water. So you're going to use a chiller, like maybe a small chiller, the one that's presented in the middle of the slide, where maybe placed literally close to the work machine that are working in the facility. Or you can have a big chiller that's placed on the roof. So,
so the second one is very interesting. I mean, it's also a way to reduce the refrigerant charge, as we said before.
Yeah, of course. So you got a small chiller.
Smaller water to water, and then you use a remote condenser.
And the traditional refrigerants, due to the quotas of the F-gas, might cost a lot of money. So.
Yeah,
or maybe there are limits due to flammability or mild flammability. We will see what happens.
So this is the technology. In the first slide, we presented what are the needs, what are the requests, what can we do. Next slide. Of course. Going back to the basics, of course, it's going to be just a brief talk about saying that the temperature is rising, we were saying before, the condensing pressure is increasing, of course, with that. So you need to get the compressor has to work more and more. So this, of course, this means more energy consumption. So the thing is, from what we see here, we just need to reduce the ambient temperature. But I think, how do you do? I mean, the temperature is year after year is growing. So how do we do to reduce this ambient temperature? The solution is in the next slide. And this what's our solution, current solution. The system is very simple. Maybe some of you may be familiar with this solution. It just, when the chiller or the dry cooler detects loss in the efficiency, it sends a signal to the cabinet that starts spraying water close to the heat exchanger.
All right. Well, let me think, Matteo. Maybe I will be really naive. Is it the same as when you go to the beach, you go for a swim, you get out, it's windy and you're so cold?
Yes, that's the effect of evaporative cooling. I mean, now we're going to winter, so it's maybe a sad memory to, but when we went to the beach, we have a bath and then go out and we feel cold. Well,
even if it's a hot summer.
And that's, I mean, we give a bath to the dry cooler.
Okay.
So we have two effects. We start with the evaporative cooling. Again, the water that's sprayed in very little droplets evaporate and cool the air. And the secondary effect is the fact that the water that's not absorbed goes in contact with the heat exchanger, and of course it cools it. So you get a double effect. So this is the solution. I think that's time to deep dive in the system. Starting, of course, with the cabinet, where you can see here in the next slide, later we'll see what's inside, but of course, here's what we already said. We got the chill booster, that's an adiabatic cooling system that you can use with chillers or dry cooler to boost the performances during maybe hot times. So that's when you need this thing.
So the cabinet is something ready, and it was made also so in a way that you can use it for a retrofit. You mentioned that temperature is rising, maybe some chillers, some dry coolers that are out there in the market were designed for a certain temperature, and suddenly they realized that they are not able anymore to cope with the peaks during the summer. That's why
and that's the thing we will see later, how this product can be useful both to new systems, so you can actually type things include it during the design stage, or if you got let's say an old system that was designed for some temperature that was back in the days, now you can install this system, so that's got a new life, let's say, to the heat exchanger.
Or maybe just an extension of an existing building that need a bit more capacity,
of course,
rather than installing a new unit.
That's
just need to upgrade it.
So what's inside this cabinet? I won't go deep and dive in every single component. I just want to, of course, underline that we got the pump. That's the main component, and we got different dimensions to be able to provide all the humidification load you may need in different installation. We got 100, 500, 1,000 liters per hour. And then another thing I want to point out is the UV lamp that you here see as an optional. You may be wondering, why do I need to kill bacteria from some water that goes on the roof?
A good question.
Yeah, makes no sense.
Right.
Actually, it makes sense because on the roof, where usually these systems are installed, you often have R&D units that suck the air and blow it inside the building.
Just the intake of the air handler might be.
Yeah, that's the thing. So you don't want any untreated water to be actually pushed inside the building. Yeah. So that's why here is an optional, but in many, many countries, it is mandatory to have something that kills bacteria inside the
Today we know how
important more than ever,
safety and sanitization is something which is becoming very, very important for everyone, and it's a
I mean, now, today, more than ever, so, but again, so here is, we gave it as an optional, but actually we suggest it in every single installation.
All right.
So, yeah, we can go on, and this is the second part of the chill booster, the distribution system. That's, of course, is crucial together with the cabinet. And it's composed by the manifolds, nozzles, and drain valves. These are the main components, of course. We got all the other pipes and fittings. But we got different dimension of manifolds and, of course, nozzles. So we can adapt to all the shapes, dimension, and, of course, water load. So if you got, for example, a small chiller, we got the small manifold, but at the same time, you got high humidification load, you're gonna need the biggest nozzles. So that's why we have all. It
has to be flexible.
Yes, it is.
Okay.
And lastly, we got these drain valves that are, of course, as the name suggests, used to drain the line. So there's no stagnant water that stays inside the system while it's not working, because again, you don't want any stagnant water. The water can be infected by bacteria.
Today we are talking about process chillers, so units which are cooling all year long, and you don't want the system to be active when outside it's very low temperature. Okay.
So speaking of water, we can go on and say that you have to know that the chill booster works with every type of water. So actually you don't have to be too careful to choose the what water, but we have some, of course, we have some hints or suggestions for you. So we can you can use tap water. That's of course the cheapest, because it's just literally the water you got in your house. But in the same time, we don't suggest use this kind of water, because together with tap water come all the salts, like sodium. So if you don't want to have to go on the roof, maybe too often to give maintenance to remove all the lime scale that may go all over your coil, you don't want to use tap water. But again, the system works with it. So if you maybe have some already scheduled maintenance, you can go with it, and it's going to be cheaper.
Well, it depends very much, I believe, also depend on the number of hours in which the system is used.
Yes. Yeah, definitely.
And on the other side, the choice, the system works with all of them. Maybe the problem is on the heat exchanger side.
Definitely, again. So that's why I want to talk about softener water, because you have to be very careful, because between those three, that's the one we don't suggest to use, because actually it got the same content in salts, but it can be even more aggressive than tap water.
So corrosion is the main issue.
Yeah, so that's, since you don't want to damage the heat exchanger, because it's the most important part of the dry cooler, you don't want to use softener water. That's why we suggest in the end to use demineralized water, that water that's where you remove all the salts. And so in the end, you can forget to have the chill booster on the roof, and say maybe once a year.
You might want to check the pH, because I remember, isn't the mineralized water maybe aggressive?
Yeah, actually, maybe you have to be careful at the beginning when you study whether the installation plan. You check what kind of water do you have on the site, and see and check if it's compatible with the heat exchanger. But definitely, we think that from our experience, that's the choice to do, because it's going to be...
Well, in the end, if you think of it, it's something close to rainwater. So yes, I expect that the dry cooler is made to be...
If the dry cooler can handle the rain, actually 90% of the time can handle the demineralized water. So, so that's why we suggest it, and that's why in the next slide we have... I show you what we have in our portfolio. We have a water treatment system that's literally the machine that produces the demineralized water, and together with the eSpecial vessel, so that it got many dimensions. And so this eSpecial vessel is used to store all the produced water, so it's ready whenever you need it from to the chill booster. So that there's no lag to wait or time
for refilling.
Yes.
Yeah. Smart.
So again, we can go on with, I think it was one of the most interesting slides of the presentation, is about the working logic. You can have two. Here I introduced start with you may be interested in reducing the temperature, the low peaks, because of course is where you're going to have the lowest efficiency. So here I have displayed two graphs where you see the number of hours where you have the certain ambient temperature in two different cities. I took Helsinki as a cold city and Palermo in Italy as one of the hottest cities. Yeah. So you see, for example, in Helsinki, most of the time you have 2 degrees during the year, while in Palermo is 14 degrees, something like that. But I think that's important to see here, the part that's highlighted, that the high temperature that's going to be for Helsinki over 26 degrees, and in Palermo over 32 degrees, they last just a few hours a year. So in a working logic, maybe to turn on the chill booster whenever the temperature goes over a certain threshold, because that's in that way you're gonna be reducing the temperature that the heat exchanger feels, and again, it's gonna be an increase in efficiency. Right. Another idea could be to, and of course it's gonna be more costly, but to turn on the system for all the summer. So for all the summertime, and it is maybe a thing that you do in a hot city like Palermo, maybe. You see here in the graph in the low part of the slide where you have the difference between the energy consumption with the evaporative cooling effect and without. And you see that during all the summer months, you got a very high effect on the yeah. It's very impressive, and see that, and that's all the work that the compressor is saving. And definitely at the end of the time.
Sometimes it was not even able to reach that point.
Yeah.
And we will see maybe in some installations. Sometimes we said temperatures are rising, and then there's a lot regarding, I remember data center. This is one of the area I'm following the most. So the fact that you expand an installation, it's not only liquid coolers or chillers, but it's also condensers, and more as there are a lot of presentations these days regarding CO2 gas coolers too. It's very, very important with CO2. I would say it's paramount to guarantee the reduction of the temperature to have the best efficiency. Sometimes with remote condensers, it is a matter of having a lot of them over a roof, for example, of a data center. So little by little you start crowding that place, and you have a sort of hot aisle effect. And all of them, they are influencing each other. And in the design point, maybe the condenser is good, whereas when you add the other ones, it's not able to reach the maximum.
And it's very interesting to hear it, because actually later with some picture on the side, we'll see a situation like this. So that's very on point. So I think we can go on. And now before, okay, there's a new slide here. So because, yeah, but
wow,
before,
that's incredible. Okay, I was
it's
captured by...
Just a hint. That's time for a question for you.
Oh, right.
So I think we can
launch the poll.
Launch a poll, yeah. I don't remember.
I'll lend you the iPad.
The number of the questions.
It must be the second one, yes.
And now I'm launching it. There you go.
So yeah, in your experience, have you ever considered to use the water isomization systems to boost dry cooler performances? So it's a question about what you lived during your work time, to see if it's ever considered to use this kind of system. So yeah, that's part of my business. Yeah, but the customers are doubtful and are not sure about all the implications and benefits they may have. Or no, I usually suggest different technologies. Or lastly, no, my business doesn't involve this technology. So maybe you're out of this kind of technology. So, I mean, you're in the perfect place to get to know this technology.
All right.
Maybe.
Shall we give them?
I think that's, if we got some numbers, yeah, I think that's, we can.
Only 30% voted. We know that we picked the last session of the day, so you might be tired.
Very tired.
We give you 5, 4, 3, 2, 1, and we end the polling. It's in any case very interesting to share the results, because
okay, it's very interesting, because actually the winner is not my business. My business doesn't involve this technology, And I think that's a good answer to have, because so now you can start to get to know this kind of technology, and maybe in the future we will
definitely, if chillers will move towards carbon dioxide, for example, it's something to take into account to reach a certain level of efficiency.
Yeah.
Right?
So I think we can move on with the presentation here, but the question is still displayed. I don't know if it's press here.
Okay.
Okay, cool.
So now I can say again, wow!
Okay, so the wow effect is here again. So these are the field data. So this is a gas cooler experience, and a gas cooler that we have installed in Italy, where we try to install the evaporative cooling system. And here you see how in red we have without the evaporative cooling system, and in blue with the evaporative cooling system. And on the y-axis, you have the index of efficiency. So you see how, as the temperature grows, the difference between these two systems. It is incredible to see if when we reach, let's say, 28 degrees, we got two, like a ER, index of efficiency with the system, and 1.6 or around there without. So
it's terrific gain in efficiency at high temperature.
It is. So, and as written here, you got with the system, we got more than 40% of energy saving in compression puzzle consumption. So that's the thing, we experienced it. So I think it was interesting. And there's a slide I always display, because
that's very, very interesting, because I mean, the chill booster was born as a booster, as a way to overcome the peaks during the hot season, let's say the end of July, what in the past someone was using just pouring water over the condenser. But here it's a completely different approach, especially for process cooling, which has in common with this experience that is for refrigeration, cooling all year long. So it's a different way of seeing that. Not to overcome the peak, but to take advantage of the seasonal efficiency. Oh, very good.
Yeah, so I can go on
and
with the last part.
Seasonal efficiency is more and more taken into account by all the norms. So it's good thing to note.
With
the last part, if you could combine variable speed and the reduction of that.
Or you might realize you don't need even to run the compression. Free cooling is is enough in certain circumstances.
Why not? Why not? Why not?
So last part, but I think one of the most interesting, because here we see different type of systems of dry coolers. We have vertical, V-shaped, horizontal, but of course I know that we got more. For example, W-shaped,
especially for chillers.
Yeah, of course. And trust me, we can install it also in that type of geometry. But here I think it's interesting to see how the system adapts to all the different geometries. So in vertical, we place the manifold literally in front, and usually we spray water counterflow, so you don't damage the fins or the heat exchanger. But the thing may be different because, for example, here you see in this shape, the manifold are placed in front of the heat exchanger as well, but we spray, in this case, we spray, I'm sorry, it's gray over gray, so it's not very easy to see, but yeah, definitely it's like that. And as I was saying, in the V shape, you can spray here, for example, in this case, on the fins, because maybe the water was treated or you checked. So we got the double effect we were speaking at the beginning. Lastly, here we see on horizontal, again, I'm sorry but it's gray over gray, so it's not easy to see, but we got two different possibilities. Here we have the system that is installed perimetral, or so all over the dry cooler, or just be under the dry cooler itself. So this type of installation, this type of decision, that's a thing we discussed together with the installer. So, and us with our experience with this product, we know what's better, just checking on site. So we see, okay, we have this situation.
Depending on the space constraints, vicinity, air distribution,
Yes.
And then you might select also depending on the behavior of the different condensers.
The thing is, what we were saying before, here you see a hot aisle maybe because in the vertical you see how the system, you got all these dry cooler one next to each other, and actually they may interact, so and reduce the efficiency. So maybe you just need a system in the middle of two dry coolers or
Okay.
So a common, sometimes it happens that you have a common system with multiple dry coolers or condensers or gas coolers more and more as we're talking about.
There's a certain modularity, so it's quite flexible. It looks like a very flexible thing.
And, sorry?
No, I mean, I can envision that in the future, it might be that this dry cooler mode with water feeding several small chillers could be a model. It's a way to reduce the refrigerant charge, so the chiller is more compact and it's water condensed, but by means of having the evaporative cooling, you could really reach outstanding efficiencies.
And this type of selection, with all the components, accessories, luckily is not made by hand. We have a software, here is between the next slide, the CPQ, and that's online, and we use it. So just starting from the inputs of the system, so you just the temperature that's actually on site, and the temperature and the humidity that you want to reach after humidification. You insert the dimension and the type of the dry cooler, and of course the airflow, and the system drives you to select the best system for your needs. So you can again decide if you want a UV lamp, for example. We were speaking the dimension or all the accessories. So it's going to be easy for you with just a few clicks to get all the list of the components that you're going to need on site. So I think that's, I mean, we just...
very handy.
Yes, it is. So it's fine.
Great.
And I think that's, we just to close in the last, just a conclusion, we went through all this product. I hope it was interesting for you to check this solution for this dry cooler and see again how this product can act and react. So can be used both for a new installation, so you are designing a new dry coolers and you install it on your new dry cooler, or you react, so you got an old system and you want to give it new life. So the dry cooler, the chill booster is the solution. And I think that's all from my side.
Yeah, we have a small question for you. I was not stopping you, but I mean, you mentioned, and in the end, that this is an adiabatic system. Many are saying, yeah, but the wet media is an adiabatic system too. What about that? How would you compare that?
But I mean, picture this: you're on the roof and you have this dry cooler. The one is displayed there, and for the wet media, you have to place literally the wet media in front of the dry cooler. But so let's say
here,
yeah, definitely, yeah, there. So is gonna, and let's say that you want to use the system just sometimes, not always. So the problem, what's the problem? The problem is that you got loss in pressure. I mean, the fans need more
pressure drops.
Some pressure drops to get all the air to enter in the heat exchanger. And this effect lasts all year long, also if the system is turned off.
Okay.
Well, so that's why I think our solution with just two manifolds is not interacting too much when it's turned off.
With the airflow, yeah.
Yeah, with the airflow, while the wet media is always there and create these pressure drops that maybe that for sure will interfere with the system all year long. So that's of course a point for us. Let's say.
Great. So it's once again, it's a matter not only of efficiency in one point, but it's overall efficiency, and in the end, what really counts, that is the real energy consumption.
Yeah, you were saying that for the process industry, the systems are always also, that's very important.
We have another question that it might be useful for everyone. I didn't catch the name of the online software. Is CPQ. That means
configure price quote, and it's online from Karel's site. Yeah.
Okay, we can enable you. And so you can play with that and simulate different solutions. Yes. So is that taking into account also the fact that we can wet the surface?
Well, actually, yes, you can actually see the benefits when you insert all the data from the site. You have a first part where you have just a calculation of the physical effect and see how is the system will behave. Of course, it depends on what we have on site, but yeah, it gives you an idea on what
the improvement that is given by the contact
system.
Evaporation.
Yes.
Excellent. So maybe it's your time. You were keeping us with your cliffhanger.
Is the attendee who asked that question still online? Because then I can.
Honestly, I don't recall who made the question. Let me go back.
Nevertheless,
anyway,
okay. The question was hot gas bypass and the new
eco-design.
Eco-design. So let's take as an example. I was thinking about how to answer while Matteo was giving a presentation of the case of high temperature process chillers. These are defined as the chillers which temperature, so they're making cold water at 7 or above degrees. Now, there's a calculation to be done at certain ambient temperatures. So you need to calculate the efficiency of your chiller. I don't remember, at 4 different ambient temperatures. And then the beams, this is the name, specific name of all the other temperatures in the between are made by interpolation. So the norm requires you to calculate the efficiency at certain temperatures. What does it mean? If you dimension your chiller, your design is such that you meet the efficiency criteria by the calculation prescribed by the norm, you might still have the hot gas bypass. So long story made short, in my opinion, yes, you can still make use of the hot gas bypass despite the higher efficiency standard required by the norms. Then it's just my humble opinion. Then of course I'll leave it to everyone.
Yes, this could be a very long debate, and very much involving also.
I don't want to trigger another 13 question, but you can contact us anytime. We have a group of experts that are, studying these sort of things in a thermodynamic lab. They have a lot of experience, so they can also provide their opinion. That maybe is more relevant than mine.
Great. Now I'm stop sharing for the last few seconds. I think we are running out of time in the end.
What's the time now, Enrico?
It's 5:15.
So thank you for keeping yourself alive with us.
Yes, we started a bit more. We used all the time. Thank you all for joining. I hope it was interesting for everyone. We have some questions. We will have some follow-ups. Someone asked for the presentation. Of course, it's something we can share. Yeah. We are happy to do that. We will see you around in Chillventa. Probably we'll be in contact. We are part of Chillventa, so you can try and contact us with a chat, and maybe we can define a meeting too, or put you in contact with the right person. It was very interesting. I think we opened a lot of new questions. We briefly touched about the refrigerants. What would be the new refrigerants of the future for process cooling? I don't know. Will it be CO2? Are we going to go back again to ammonia? I've seen there are a lot of presentations and during these interesting sessions for Chillventa. We all hope it was interesting. Any other comments from you guys?
Thanks a lot for joining us today. Of course, we didn't pretend to cover every possible topic. We decided to have a clear focus on process chillers applications. Let's leave the other, points of debates to other arenas. But thank you again from my side for being with us today.
So yeah, thank you from my side as well.
Very good. Okay. So thanks for joining. That was very interesting. I hope this will raise a lot of debate, and so we can get in contact as expert of this industry. Absolutely. We can share our opinion. We won't be able to share our bratwurst and the beer, as normally it happens after Chillventa, but we will definitely have occasion to get in contact and talk about high efficiency even in process cooling, yes. So act now, save energy, and stay safe. Yep. Okay. We'll be in contact. Thanks for joining. Thanks for attending. On behalf of Karel, we'll see you soon. Cheers. Bye.
Ciao.
Ciao.